All right, here we go.
He doesn't have big brain, okay?
All right, now. You talking about me?
Yes. Yes, sorry.
I mean, I do have a small head. I had to put a
No big brain.
because.
Just fall like
This is my dad's hat. Anyways,
Your dad
moving
just
on.
has that?
It was a joke because it was too big for me.
Oh.
So that was not.
Why would your
that
dad
was
have
that.
a bigger hat?
Anyways, now the video, or not the video, the demo. Small. All right, so
I lost it.
just so you have the visual here, so we're gonna do it again next week. So what did I put in here? Ethanol, flammable liquid. Now I poured some in, I kind of coated the inside, and then I dumped the excess out. That's important. Then I put the cork on, not super tight. If I put it on too tight, there's a chance these things are going to get blown out. We want this to fail first. So if we were to seal these and throw them on a fire, which is an awful idea, chances are the first thing that's going to go or crack or break is something up top near the cap, because that's where it's going to be weakest, right? So same thing here. Hopefully this is the weakest point, and the cork shoots out. And next week, if you remind me, we'll put a bullseye up here.
Ooh,
See what I can do, and we'll have. You're going to record, and you can do slow mo. Yeah, slow mo is awesome. I do have it somewhere, either on my website, channel, whatever it is. I do have slow mo of this, and it's really cool seeing the fire inside. And typically this thing flies, and I kind of do something like that, and it's funny on slow mo.
I even saw the quote fly out yesterday.
You did or did not?
I thought
Yeah, no.
No, my eyes
So
were shut.
yesterday
I
was
just
a little supercharged. I think I put it on a little too tight.
Yes.
That was louder than usual. All right, now, well, that's why everyone was behind me, because even if worst case something happens, you should be fine. Now, you're gonna write right now a sentence or two. Why did this work? Now, don't just tell me because there's a flammable liquid. I need more than that, right? Because if I did it with water, it wouldn't work. Because as soon as I forgot to reiterate that part. When I hooked up the taser, essentially.
It's a taser?
Well, that's kind of what it is. I touched the screw with the Tesla coil, and the electricity actually arced between the two screws. Have you ever seen electricity arc before, or have you heard of that? If you have electricity running from one metal to another, and you get them close enough, a certain distance, the electricity will jump from one to the other. It's called arcing. If you ever scuff your feet on the floor, touch a doorknob, get a shock, it's essentially there's arcing there.
Say that lightning is working.
Kind of, yeah, because it's going from to the ground. Yeah, lightning's kind of like a giant arc. Think of it that way. All right, so I needed the electricity, or this wouldn't work, right? So in a sentence or two, try and come up with why did this demo work? That's it. Don't tell me just because there's a flammable liquid. I need a little bit more.
Did you get the screw wet?
Well, maybe by mistake, but that's not the point. The screws are just there to conduct electricity. So why did that demo work? What's the principles behind it?
Bless you.
Thank you.
So, the next phase of notes will be liquids. Now, the thing with liquids, though, is I'm just going to talk while you're writing. Hopefully that's okay. So, liquids change phase pretty easily if you heat them up. So that's a little bit of a hint. And that's what we focus a lot on with this liquid part of the notes. What happens when it evaporates. Question or comment?
Question.
Okay.
What makes the art? Why is it green?
So, electricity, you might know this. What's electricity always trying to do?
It's trying to get
the fastest way to the ground, essentially. That's why grounding wires and things that are grounded are important, because that's what electric. If you have like a grounding rod outside your house, and your house is grounded, if your house gets struck by lightning, it'll go through to the ground as fast as possible, and not spread out through your house. I don't know if every house is grounded. They're supposed to be, but I bet not everyone's house is. And that's especially important if you have like solar panels, let's say, so you don't want to fry those. But anyways, if you have, so I had that Tesla coil and I held it, I think, to this side. I don't know if you guys noticed, but I held this side to the faucet. So I was grounding it essentially. Now I wouldn't have to do that, but it's just safer so it doesn't go into me by mistake. But yeah, when I touch the Tesla coil here, the electricity senses, this is going to sound weird like it has a brain, that there's another substance near it that conducts. So the electricity will try and run through whatever it can to get to the ground as fast as possible. This distance is close enough where it will make that jump because metals conduct very well. So senses is not really a good way to explain it, but I'm trying to get you to understand that the electricity, if it's near something that will conduct it, it will run through that or it will jump to that. The distance is different, and I don't know how to explain that, but.
What makes the arc?
Oh, because there's space. So, because you have a conductor and then non-conductor and then a conductor.
No, but if it's electrons, they're super small, so you should be able to see it. So what makes it so you can see it?
Oh, because there's literally billions of them at once coming out of that Tesla coil. So like a spark or like a shock that you can see, or like lightning, billions and billions of electrons together. So then you can see it.
So that's just pure electrons then?
That's what electricity is, yeah.
Okay. So
Yep.
You're saying that electrons are blue.
Electrons are what?
Are blue because it was a blue particle.
Yes, the color varies, right? Sometimes lightning isn't that, but now remember, colors just has to do with wavelengths of light emitted that our eyes pick up. But yeah, it looked blue. Yeah. Sometimes they look purple. Yeah.
So, because they jump, how those electrons affected by gravity? Is that why they have to jump? So that they just-
I would say not really. I mean, they don't really have a mass, but they're arcing or jumping because of the gap between the metal. As far as the shape of it, that's a good question. It's got to have something to do with the electric field. All right. Anyways, good questions, but a little bit off topic. What?
Okay, if we weren't paying attention to like half of what you were saying, Nicole.
Yep, that's fine.
Okay, good.
All right. Anyone want to read what they wrote?
Mine doesn't make
Yeah,
sense.
keep that out. I have you guys write things a lot because on the Regents, you have to write. You can't verbally answer Regents questions. You have to write. Go ahead.
Well, the liquid vaporized when the electricity went through because it got heated up. And then the vapor that formed made a high pressure inside the bottle and the cork couldn't blast against that. So the cork got pushed out by it and everything blew up.
Good, good. Everything you said was good. I'm going to add a little more to it. But when I put the ethanol in the bottle, why did I swirl it around?
So you can get everything.
So I coated the entire inside. What? Someone give me a term, science term for that. Surface area. There's more surface area. So if I take a glass of water and I dump it on the floor and spread it out, and then I have a glass of water that's the exact same volume as the water on the floor, which one's going to evaporate first?
It's spread
The
out.
floor. The more you spread a liquid out, the better it evaporates. So I wanted that to evaporate. I wanted that to evaporate very quickly. Why? Because it builds pressure. That's the whole point of the demo. And then when I added the electricity, it heated up the vapor, literally like in milliseconds, and the particles started moving so fast with so much force, the cork couldn't handle it and just got forced out because of the increased pressure. So, if I just left that sitting here and I didn't light it, ignite it, it would still build pressure, but it really wouldn't blow the cork out. So using the electricity ignites that, and it excites the particles, they gain kinetic energy, and the force increases dramatically, collisions, pressure, shoots it out. So it's important to understand that's why I did that. Why did I dump out the excess?
So we didn't like catch.
Too much is not good. The whole thing could blow up. Okay, if there's too much pressure. And this might blow your mind.
Yeah, but pretty catch again.
Liquids
No exist.
cannot burn.
What?
How flammable? Vapors are.
It's the vapor just above the surface of the liquid. So if you had a bucket full of
And
gasoline,
you
don't
put
try
the
this,
match
Luke.
and you just- no,
If
I've
you have a
done it
bucket
before.
full of gasoline, you take a match and you plunge it into that like very quickly, you might be able to put it out in the gasoline.
He's done it
It's
before.
happened.
I've done it.
There you go.
before,
See,
come on.
it's the vapor that catches fire, not the liquid. That's an important thing to understand about chemistry.
An empty gas tank to the
The
job.
gasoline vapor is not the
Oh,
gasoline.
it ended already?
Yeah.
Already?
Tomorrow, ask that question. Is it relevant to that conversation?
Wait, why is there a fire then? There's a small fire that goes up.
It's not a question of
It's
when
because of the
you
vapor.
Oh, because the vapor in there
Oh,
ignites.
yeah.
It's like when you pour gas on a fire and you have the little burn that shoots out.
Yeah, you're right.
So you said you would give me the book on Monday?
Yeah, I mean, I can give it to you now, but you won't know how to do it.
Oh, wait.
Yeah, just wait.